Just imagine this. A world where anime artists can effortlessly transform intricate line art into beautifully colored masterpieces faster than ever before. That's the vision behind MangaNinja, an AI-powered tool that's revolutionizing the art of line art colorization. It blends diffusion models, patch shuffling, and interactive point guidance, all while making complex tasks look simple. Today, we'll explore how this model handles challenges like mismatched references and multi-character compositions, and why it's a game changer for the anime industry. So buckle up, it's time to dive into the colorful world.
All right, let's dive into this fascinating paper about MangaNinja, a system that's all about bringing black and white line art to life with precise colorization. Imagine you've got a sketch, maybe a manga character, and you want to color it, but you want the colors to match a specific reference image. That's exactly what MangaNinja does, and it does it with incredible accuracy. Two standout ideas power this approach. One is the patch shuffling module, an image. This module learns how to pair regions of the reference image with parts of the line art, making sure each color lands in the right spot. The other idea is a point-driven control system. That means users can manually fine-tune specific areas, giving a lot of freedom to tweak details as needed. The paper also shares how MangaNinja performs in practice, showing it does really well on a custom benchmark. It even offers the possibility of speeding up workflows in the anime industry. Now look at Figure 1 here. You'll see how the entire process unfolds. We start with just a black and white line art and a reference image, then generate a fully colored piece that's both vibrant and accurate. Let's dig deeper into how MangaNinja tackles the tricky task of line art colorization. At its heart, it transforms black and white sketches into color images, all while staying faithful to whatever reference you choose. This is especially useful in manga or comics, where consistent character features and details are crucial. Why is this a challenge? Traditional methods often assume the line art and reference match almost perfectly. But that's rarely the case in real life. MangaNinja addresses this with a dual-branch structure that captures global and local features. The key here is a patch shuffling module, which divides the reference image into patches. By shuffling these patches, the model learns how to align even small details, preventing errors when the line art and reference aren't exactly alike. Then there's the point-driven control system. It steps in for situations involving shadows or complex patterns. This system lets you place guiding points so you can directly influence how specific areas are colored. It's especially handy for small but important spots like facial features or garment details. Data for training came from anime videos. Pairs of frames were used as training samples to ensure the model could handle everything from mismatched poses to multiple references. Quantitative tests show that this model preserves both image fidelity and character identity better than existing solutions. Now let's see how MangaNinja incorporates pre-trained diffusion models for consistent line art colorization. Traditional techniques often rely on large, fully labeled datasets or handcrafted features. Those can be expensive and tough to scale. MangaNinja leverages diffusion models that already have rich image priors, which cuts down on the need for exact pixel-level labeling. The system classifies consistent generation into 3 strategies. First, some approaches require little to no training, simply adjusting attention layers or guidance signals. Second, there are methods that fine-tune on just a few examples, which can be efficient but sometimes slow. You can train a diffusion model on a specific dataset, encoding many details into the network itself. While those methods work for broad tasks, they often lack pinpoint accuracy. That's where MangaNinja's targeted reference matching comes in. Look at Figure 2. You'll see how point guidance corrects mismatches in pose or detail between line art and reference. Users identify corresponding points on both images, ensuring details like faces or clothing are synced. This approach is also helpful when colorizing frames in a video, where scale and angle often shift. Finally, the overall pipeline uses points to match line art and reference images. Tools like light glue help with precise feature matching, so you get vibrant colors exactly where you want them. Here, we get a closer look at how MangaNinja is trained. The system starts with 2 frames from an anime video, one as a reference, and one converted to line art. The reference goes to a reference UNet, and the line art heads into a denoising UNet. Together, they align both large-scale and subtle details for consistent colorization. Check out Figure 3. It illustrates the progressive patch shuffle technique. The reference image is split into patches, which are randomly shuffled. This forces the model to pay extra attention to local details. Over time, the degree of shuffling increases, helping the system handle more complex matching challenges. The reference U-net extracts features and feeds them into the denoising U-net at multiple layers. This layered fusion ensures the model learns both broad shapes and minute details. Then, the denoising U-net uses that information to rebuild a colorized image from the line art. You'll also see fine-grained point control in action, where users can mark points on both the reference and line art. These guides help the system handle tricky parts, like faces or busy patterns with precision. The end result is a mix of automation and user input, balancing speed with creative control. Here, the focus shifts to training strategies and evaluation. First, the PointNet module is central for fine-grained user control. You can define up to 24 matching points between the reference and line art. These landmarks align important details, like a character's eyes or unique patterns on clothing. Don't feel like adding points? That's okay. The model can handle automatic matching too. PointNet processes these points through multiple layers, then uses cross-attention to integrate the information into the main model. A technique called condition dropping removes line art guidance during training, pushing the model to rely on those sparse references more heavily. The two-stage training process further refines PointNet, starting with broad correspondence learning, then specializing in point-based control. For evaluation, the authors propose a thorough benchmark of 200 anime image pairs. They look at metrics like clip and dino scores, plus PSNR and MSS sim for structural accuracy. In more complex scenarios, they even do pixel-level checks using predefined points. This detailed analysis ensures MangaNinja remains accurate in all sorts of challenging colorization tasks. Now we see how MangaNinja compares to other colorization methods, both in visuals and numbers. Look at Figure 4, which compares MangaNinja to methods like Basic PBC, IP Adapter, and AnyDoor. Basic PBC often misses proper lighting or shading when the line art and reference don't match well. IP Adapter and AnyDoor, which use diffusion models, can color large areas but miss fine details. MangaNinja excels here, even without using manual points. The progressive patch shuffling it underwent during training allows it to handle both simple and complex alignments. On a benchmark of 200 image pairs, resulting in 400 tasks, MangaNinja demonstrates higher accuracy and better visual quality than its competitors. That pixel-level precision is critical, especially in art, where small mistakes are easy to spot. Let's continue with more comparisons. In Table 1, you'll find a quantitative breakdown of how MangaNinja stacks up against Basic PBC, IP Adapter, and AnyDoor. You'll see the numbers favor MangaNinja for metrics like pixel accuracy and perceptual quality. Better yet, this holds true even without point guidance. When users do add points, results are even more precise. Figure 5 shows how point guidance handles tough scenarios, such as line art missing details or drastically different poses. This system can fill in missing clothes or manage interactions between characters and objects, all without creating color mistakes. In Figure 6, you'll notice how MangaNinja can juggle multiple reference images at once. By assigning points to each reference, the model resolves any conflicting color information. Everything comes together for a unified, colorized result, illustrating how versatile the system can be. Finally, let's wrap it up. Table 2 provides an ablation study that breaks down how each training strategy contributes to final performance. The authors test 6 versions of the model, measuring metrics like PSNR, SSIM, and MSE. Techniques like condition dropping and progressive patch shuffle make a big difference, improving automatic matching by teaching the model to focus on local details. Figure 7 shows the model dealing with references that differ significantly from the line art. Using point guidance, you can fix mismatched parts. Think of characters with different outfits or styles. It's an interactive process that helps you refine the final look. The conclusion points out MangaNinja's main contributions: reference-guided colorization with dual branch networks and PointNet, capable of handling big differences between references and line art. By combining patch shuffling, point-driven control, and a robust training scheme, MangaNinja produces colorizations that are both accurate and easy to adjust. And there you have it. MangaNinja, a system that's not just about adding color, but doing it with precision and creativity. Whether you're an artist, animator, or just someone who loves manga, this tool opens up a world of possibilities. So next time you see a black and white sketch, imagine what it could look like in full color, and know that MangaNinja is here to make it happen.